Next property is time scaling property. So next is state and prove. State and prove time scaling property. So first we write the statement. If x of t is Fourier transform x of f and phi is constant, then x of alpha t its Fourier transform is 1 by alpha f by alpha. So we have to prove this time scaling property. So we write down the proof. Now according to the definition of Fourier transform, standard definition, we write here. According to definition of Fourier transform, ft x of t is x of f integration minus infinity to infinity x of t e raised to minus j 2 pi f t dt. Therefore, f of t x of alpha t is equal to integration minus infinity to infinity. We replace this t by x of alpha t e raised to minus j 2 pi f t as it is dt. So put alpha t is equal to k. Therefore t is equal to 1 by alpha into k and dt is equal to 1 by alpha into dk. Okay. So we substitute these values in above equation. Therefore f of t x of alpha t equal to minus infinity to infinity x of k into e raised to minus j 2 pi f 1 by alpha into k into 1 by alpha into dk. So we substitute above values here. it is equal to 1 by alpha integration minus infinity to infinity x of k is to minus j 2 pi f by alpha into k dk. So this is x of f by alpha. Therefore we can write here ft of x of alpha t, it is 1 by alpha x of f by alpha. Now if alpha is negative, then ft x of alpha t is, we can write equation for this also. If alpha is negative, then ft of x of alpha t equal to minus 1 by alpha x of f by alpha. So we can write the generalized formula as ft of x of alpha t is equal to 1 by mod alpha So this is more generalized formula. Now x of alpha t represent the expansion in time domain, and x of f by alpha, it represent the compression in frequency domain. So the expansion of signal in time domain corresponds to the expansion in frequency domain and vice versa. This x of alpha t represent expansion in time domain, and this represent expansion in frequency compression in frequency, not expansion, this is compression in frequency domain. So expansion of signal in time domain correspond to the expansion in frequency domain and vice versa. Now next is state and prove time shifting property. So first we write the statement: if x of t, its Fourier transform is x of f, then x of t minus t0, its Fourier transform is e raised to minus j2 pi f0 x of f, where x of t minus t0 indicate delay. That is, delay means what? Time shifting. Of x of t by positions. So this is the statement, and now we have to prove it. Now, according to the definition of Fourier transform, according to definition of Fourier transform, so Fourier transform of x of t, it is x of f, which is equal to minus infinity to infinity, x of t e raised to minus j 2 pi f t dt. Therefore, f t x of t minus t0 minus infinity to infinity, x of t is replaced by t minus t0, so e raised to minus j 2 pi f t dt. Now we substitute t minus t0 is equal to k. So we write here, put t minus t0 is equal to k. Therefore t is equal to what? t0 plus k. Therefore dt is equal to dk. Now ft of x of t minus t0 t minus t0, it is equal to minus infinity to infinity x of k e raised to minus j 2 pi f t0 plus k into dk, which is equal to minus infinity to infinity x of k raised to minus j 2 pi f0, sorry, not f0, f into t0 e raised to minus j 2 pi f k. We just separate these two terms into dk. Now e raised to minus j 2 pi f t0 outside the integration, it is x of k e raised to minus j 2 pi f k dk. So this term is x of f. So we can write down f of t x of t minus t0, that is Fourier transform of x of t minus t0 is e raised to j2 pi f t0 into xf. Not this total term, this term is x of f. Okay, this term is x of f. So in the case of communication system, the signal transmitted from the transmitter, it takes some time to reach to the receiver, that is it is delay by some amount, say t0. The Fourier transform of delay signal is e raised to minus j2 pi f t0 into xf. It indicates that the amplitude in Fourier domain is not changed, but there is an additional phase shift of minus j2 pi f t0. So this is time shifting property. Next is next is not property, it is related to area under curve x of t. So this property actually. Next problem, state and prove area under curve x of t property. Statement: if x of t its Fourier transform is xf, then area under curve of xt is x of 0. So we have to prove it. So proof, basically area under curve means what? We write here, basically area under curve means minus infinity to infinity x of t dt. Now according to Fourier transform, according to definition of Fourier transform, x of f is equal to minus infinity to infinity x of t e raised to minus j2 pi f t dt. Now consider this as equation 1. This is equation 2. Now at frequency f equal to 0, equation 2 becomes x of 0 equal to minus infinity to infinity x of t e raised to 0 dt. Therefore x of 0 minus infinity to infinity x of t dt. This is equation number 3. Now from equation 1 and 3, from equation 1 and 3, we can say that area under curve is integration minus infinity to infinity x of t dt, which is equal to x of 0. Now if we evaluate Fourier transform at zero frequency means at f is equal to 0, then it gives the area under curve of x of t in time domain. If we evaluate Fourier transform at zero frequency, that is at f equal to 0, then it gives the area under curve of x of t in time domain. Next, fifth one, state and prove. Area under curve except property. Area under curve x of f property. So first we write down the statement for this. If x of t, its Fourier transform is xf, then area under curve of xf is x of 0. So we write down the proof for this. Now area under curve of xf means what? Area under curve of x of f means minus infinity to infinity x of f df. So consider this as equation number 4. We continuously give the numbers. This is equation 4. Now according to definition of inverse Fourier transform, x of t is equal to minus infinity to infinity x of f e raised to j2 pi f t into d f. This is equation 5. Now at t equal to 0, at time t equal to 0, equation 5 becomes x of 0 is equal to minus infinity to infinity x of f e raised to 0 df. So it is equal to minus infinity to infinity. X of f e raised to 0 is 1. So it is there. This is equation number 6. Now RHS of equation 6 is same as equation 4. Okay, the RHS of the equation 6 and equation number 4 both are same. So area under curve XF is x0. Thus area under curve x of f is x of 0. So this is area under curve xt property and area under curve x of f property. In this way we can prove both the properties.